What I really want to get into next are the ordered pairs, looking at this as an XY combination. Okay, and we can look at a list of ordered pairs or a table, an XY table. So let's start with that, and that can give us a pretty good idea of what the graph will look like. Okay, so if you think about the inputs being the angle and the outputs being the ratio, they have opposite to hypotenuse. Well, and remember again that that ratio must always be between -1 and 1, and that's because the hypotenuse is always the larger of the sides, right? It's always bigger than the opposite side, and so that denominator is always bigger than the top, which makes it a fraction less than 1. There's of course a time where they're the same, which would be where they equal 1 or -1, and that's like at 90 degrees and 270. Okay, so when we think about the input-output here, our angles are going to be the input. So I'm going to go ahead and represent them in radians, and we're just going to use some of the ones that we're familiar with. So again, I'll stick to like the 30, 60, 90 and the 45, 45, 90 triangle idea. We'll start with 0, because we've dealt with the unit circle, we've dealt with 0 radians. We've also dealt with 30-degree angles, which are pi/6 radians. We've dealt with 45-degree angles, which are pi/4 radians. So remember, this is 30 degrees, 45 degrees, and of course pi/3 radians, which is 60 degrees, and then pi/2 radians, which is 90 degrees. So these are sort of the values that we're familiar with based upon previous discussions. So now we're just going to look at the outputs. Well, we know that the sine of 0 is 0. We dealt with that when we looked at the unit circle in a previous video. So the sine of 0 is 0. The sine of pi/6, or 30 degrees, is going to be opposite over hypotenuse. That's 1/2, or 0.5. There's a reason I'm going to convert these all to decimal form. It's a little bit easier to plot the graph of a decimal than it is to plot the graph of, say, a square root of 2 or something like that. So when it's in decimal form, we can plot it easier. If I want the sine of pi/4, well, of course that's 1/√2, or if I rationalize the denominator, it's a √2/2. And the decimal form for this, if you punch this in your calculator, it will be approximately 0.707. Okay, there's of course an infinite number of decimals. This is an irrational number, but I'm just rounding it so we can get a decent idea on the graph of where that is. The sine of pi/3. Of course, pi/3 is a 60-degree angle. That would be √3/2, which when punched into a calculator, you'll be able to find that that is 0.866 approximately. Okay, again, it's irrational, so there's an infinite number of decimals there. And then the sine of pi/2 we found when we did the unit circle discussion previously. Again, the sine of pi/2 ends up being 1. That ends up maxing out the value of the sine. Okay, so that gives us our sine values kind of going counterclockwise through the first quadrant. Remember, the sine then is going from 0 to 1 as you trace out that first quadrant. As you go into the second quadrant, remember again from the unit circle idea that the values are kind of mirror images. You know, you would start up at 1 and then go back down to 0. And again, the sine is positive in both the first and second quadrants, so it's all going to be positive values. So you have this mirror image as you go into the next quadrant. If I were to go with, let's see, another 30-degree angle. Now remember, when we add our pi's here, our radian measures, we can do them in increasing fractions. So if I want to go to a 60-degree angle over here, that would actually be a 120. So it's 90 plus 30 is a 120 degree angle. And that would be, let's see, 1 pi over 3, 2 pi, or pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which is 2 pi over 3. So it'll be 2 pi over 3 is our 120 degree angle. And that then would have this mirror image around 1. So you'd have the root 3 over 2. And then when you go to the 45 degree angle over there, which is actually 3 pi over 4, that would be our root 2 over 2. And then you go back down, so that would be, what's that, 5 pi over 6 is the next one. And that would end up being our 1/2. And then when you get down to 180 or pi, that would be, again, back down to 0, okay? As you then go down into the third quadrant and the fourth quadrant, you again have a mirror imaging of these values going back up. So next would be a 1/2 and then root 2 over 2 and so forth, but they'd all be negative because remember the sign is negative in the third and fourth quadrants. Okay, so as you come around, sign is positive, positive, and negative, okay? So you're going to have the negative values over here. So let's go through, we'll start tracing these out on a graph and then we'll see what the negative values end up doing. So let's look at plotting these out. Oop. Let's try to get a good graph going here. All right, I'm going to draw more of this going in the positive direction because I've got my positive angles. We will look at the negative angles as well shortly, but not just yet. Okay, so as I look at this, I want to go up, well, let's go to 2 pi. That way we can see everything that happens in one full cycle. And then after that, it's just a repetitive pattern. Once you go around this circle once, when you go around the circle twice, you're just repeating everything from the first cycle. And if you go around backwards, you're repeating everything again, just in the other direction. So if I can get from, let's say, 0 to 2 pi, and I get a really good idea of what that looks like, then I can just sort of copy and paste, right? And just keep doing that, and then copy and paste it backward as well. So we go 0 to 2 pi, because that gives us a full cycle. And of course, we know I haven't plotted out up to pi. So I'll cut that in half because half of 2 pi is pi. And then I kind of know where some of these other ones are, like pi over 2. It's half again, right? Half of pi is pi over 2. And of course, in between pi and 2 pi is 3 pi over 2. Okay, so that gives us a starting point. That gives us basically our 90 degree angles, right? 90, 180, 270, and 360 are all represented here. If I wanted to find the halfway point of each of these, that's really using our 45 degree angles. And we can do that as well. Halfway between 0 and pi over 2 is pi over 4, right? Half of a half is a quarter. And then you have 3/4. That's 3 pi over 4. And then 5/4 and 7/4. So 5 pi over 4 and 7 pi over 4. And so we're just assembling a number line with a bunch of fractions essentially, and those fractions have pi associated with them. Okay, so 1/4, 1/2, 3/4, 1. Think of it like a ruler almost with inches, right? You got a 1/4 inch, 1/2 inch, 3/4 inch, 1 inch. And then you got 5/4, 3/2, 7/4, 2. Okay, and so on. Okay, so I don't have my pi over 6 and pi over 3 angles in there because I'm starting to crowd this number line in, but we'll be able to estimate it pretty close. Now vertically, I know that my highest value is 1, my lowest value is going to be -1. So let's go ahead and put in 1 up there at the top and -1 down there at the bottom. And of course, our number line might go farther, but our graph isn't going to, so that we can stop it there. 1/2 is actually on the graph. So I can put 1/2 and -1/2 on there. And then other than that, some of these other values I'm just going to have to estimate. Okay. Actually, I might even put 0.5 just because it looks a little nicer. 0.5 and negative 0.5. There we go. Okay, and so now we just need to graph this thing. Plot the point. So 0, 0 is on the graph. This is my y, this is my x. So 0, 0 is a point on the graph. Followed by pi over 6, comma 1/2. Well, pi over 6 is kind of a sixth of the way to pi. So it's kind of between 0 and pi over 4. So it's in here. And you go up to 1/2. So it comes up right about there. It's somewhere between 0 and pi over 4, and it's up to 1/2. Then at pi over 4, you're actually up to 0.707. So right here at pi over 4, we could bring that up, and somewhere up here, actually it's not quite, I'm thinking about that, 0.75 would be halfway between these two markings, so it's a little less than halfway. Right about there, maybe. Then at pi over 2, you've reached your max of 1. Okay, so there we are. We've got our first 4 points essentially plotted. Now, of course, we can input other angles, any angle between 0 and 30, or all the angles in there, any number we want. And so I've only picked out 4 nice ones in there. 5 nice ones. What am I missing? I'm missing one, aren't I? Oh yeah, I'm missing the 0.866. At pi over 3, which is between pi over 4 and pi over 2, would be at 0.866. So that's up here. There we go. So there's actually 5 points that we could plot. And of course you could fill in other points as well, which we don't know the values, but they can be found. And so you end up with a smooth curve, all connected, kind of arching its way up from 0 to 1. Okay. Once you hit 1, that's your maximum. This starts to drop back down. You get your 0.866 and back down to your 0.707 and back down to your 0.5, and then eventually down to 0 at pi. So over here you're at 0, and in between it just kind of drops back down to there. Okay? So I'm not going to go through and plot every point, but at least you see the trend developing. Now, what happens is, as you go into the negative side, right, you get to the 3rd quadrant and 4th quadrant, that would be the next half of pi and then the next half of pi. You're essentially taking negative outputs. You're taking all these values, but putting a negative on them because the sign is negative in those 2 quadrants. Okay, so if you take a mirror image of this and put it down below the x-axis, essentially, then at 3 pi over 2, you end up at -1, somewhere about there, and the graph kind of curves down to that point and then back up to 0 at 2 pi. So you have a mirror image of the left side repeated underneath on the right side. Okay, and I could go through all the details of that, but I'll kind of spare you those details because we've already seen it with the positive side. Okay, all right, and so that gives us a decent graph. What ends up happening then is if you were to go around the circle a second time, the entire thing repeats, cut and paste, or copy and paste, and you keep doing that forever. And if you go backward, if you went clockwise around the angles, you'd be doing negative angles, and you again copy and paste all the way back. And so what we end up with is kind of a wave shape. Some people even call it the sine wave. Okay, in the sine wave, just a real quick, I'll kind of imagine zooming out for a moment and seeing all those waves. You start at the origin and just kind of waves back and forth between -1 and 1, and it does the same thing going to the left. Okay, and each jump from where the graph starts to where the graph repeats is a distance of 2 pi. Okay, So 2 pi to that spot, and then a full wavelength again would be at 4 pi, and here would be a 6 pi. So it's all even multiples of pi. Every 2 pi, the graph essentially starts over, the wavelength starts over, okay? And so we call that gap the period, okay, the repeating portion of the graph, the length of that single wavelength.